Okay, welcome to another activity video here. I want to back up a little bit and remark about a problem from activity 3, well, 4 problems from activity 3. And so what I said was I gave you a quadratic, y equals 3x squared plus 7x minus 6. And I said, all right, factor this equation, find the x-intercepts, find the y-intercept, and then graph it. And I just pulled this. Most of them are wrong or only halfway done. This was someone's solution. This is the entire solution. There were some axes here, and then a parabola, and then something like this. This is the entire solution. I think there was a point there, so I think maybe this implied that was 6, 0, because those kind of match, but this is not that. So it's possible that we're not really clear on what we're doing with quadratics. So we're gonna take a deep dive into this quadratics. And even though it's something I know you've seen before, and you're probably seeing in Math 100 right now, the idea with this lab is to go even deeper. Okay, so let's just go back to the beginning here. Okay. With a definition. Quadratic equation has the standard form y equals ax squared plus bx plus c, where a is non-zero. Now this is important because if a was 0, all we'd have is a line, and we'd be talking about nothing new. So it's okay if b and c are 0, but a must be non-zero. Otherwise, we're not talking about quadratics. We're talking about linear equations. Okay, so trying to make this as clear as possible. A. The points on the graph of y that intersect the x-axis are called x-intercepts. At these points or points, y equals 0. Now this seems intuitive to me, but let me explain. If I have my xy axes here, and I have some parabola, which is the graph of a quadratic, it's going to intersect the x-axis here and here. Now at these points, y is 0. Right? It's not 1, 2, 3, because if you labeled these 1, 2, 3, no, it's at these 2 points, y is 0. So whatever these two are, it's going to have an x-coordinate of, say, p and a y-coordinate of 0, and an x-coordinate of q and a y-coordinate of 0. So maybe that was missed. I don't know. But nonetheless, here it is. So this I'll call the point p, comma 0. So this would be p on the x-axis. And then this I'm going to call q, comma 0. But the important thing to note here is that when you have an x-intercept, the value of y is 0. Okay. So if we return to the equation here, if I take this guy and I go, I want to find the x-intercepts. Well, I know that y is 0, so I just put 0 in place of y, ax squared plus bx plus c. solve this equation for x. And the points you get are the x-intercepts. This is why you learn how to factor in the first place, so that you can find out what the x-intercepts are. Okay, so returning to our example from the remark above, 3x squared. We want to find the x-intercepts of this guy, so we set it equal to 0. And now we factor. Okay, let's see here. I need to do some work. 3 times minus 6 is minus 18. And then I have 7. So I'm looking for two numbers. When multiplied, give me minus 18. And when added, give me 7. So what are they? They are 9 and 2. And I put a negative there. So 9 times minus 2 is minus 18. 9 plus minus 2 is 7. Okay. The 3x squared goes here. The minus 6 goes here. The 9 goes here. And the minus 2 goes here with an x. And now we do this x box thing here. This is 3x and x plus 9 minus 2. So let's check. 3x times x is 3x squared. 3x times, that should be a 3. 3x times 3 is 9x. X times minus 2 is minus 2x, and 3 times minus 2 is minus 6. There we go. So we factored it. This is one factor, and this is the other factor. We set it equal to 0 because we're looking for the x-intercepts. So by the zero product property, this says either x plus 3 equals 0, or 3x minus 2 equals 0, or both. So we solve this for x. We get a linear equation here. And we solve this for x, and we get this guy, right? Okay, so the x-intercepts are the points minus 3 comma 0, because it's the x guy that we found here, and 0 for y, because that's where the x-intercepts happen. And then 2/3 comma 0 here. So that's the other x-intercept. Okay. So now let's find the y-intercept. Now again, if you're looking at some graph here, there's the x and y axes, and you're looking for the y-intercept here, find the y-intercept at this point, x equals 0. I mean, look, if you're on the y-axis, x is 0. It can't be 1, 2, or 3 because you wouldn't be on the axis. So all you do is plug in x equals 0. Okay, and if we do that, we get y equals 3 times 0 squared plus 7 times 0 minus 6, which is minus 6. Right? And it's important to note that every time the y-intercept is just c. Because for any a and b, if you plug in 0 for x, and this will be y, you get y equals c. Okay? So the y-intercept is minus 6, 0. Okay? So now in this problem, we found two x-intercepts, one y-intercept. And so let's put this on an axis, a set of axes. So here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is x. This is y. Okay, let me make sure I get everything on the screen here. Can I see that? Yes. So first, let's put the x-intercepts on there. I have 1 at minus 3, 0. And then I have 1 at 2/3, 0. About right there. I'm going to put in the y-intercept. It's at minus 6. That's down here. I know that a equals 3 is positive, so this guy's going to open up like that. And there's a scat. I think the vertex is probably a little lower here, so maybe you go like this. I'm not really concerned with the vertex right now. I'm concerned with finding x-intercepts and y-intercepts and then getting a graph up here. Okay. So note. What if this thing is not factorable, right? What if you can't factor the left-hand side of this thing to get the x-intercepts? Well, we know that if you want to solve the equation 0 equals ax squared plus bx plus c, which is code for saying we're looking for the x-intercepts, by the quadratic formula, you get this. This gives you 2 points, and those are the x-intercepts. So if we return to our last problem, the same one we're working on here, y equals 3x squared plus 7x minus 6. And let's say you didn't feel like factoring, or you felt that this is not factorable, and you wanted to find the x-intercepts. Then what you do is you take 3x squared plus 7x minus 6, set it equal to 0, and then plug it into this formula. I hate this thing, but you know, there it is. It's okay, I'm gonna do it once. It's minus 7 plus or minus the square root of minus 7 squared is 49 minus 4. What's A? A is 3 and C is negative 6. All over 2 times A. Okay. I'm gonna move over here. So this is minus 7 plus or minus the square root of 49 plus 12 times 6. So I think that's 72. Yeah. All over 6. 49 plus 72. I can't do that in my head. That's 121 over 6. So this is minus 7 plus or minus 11 over 6. Is that right? 9, 10, 7. Yeah. So minus 7 plus or minus. Okay, so minus 7 plus 11 is 4/6. And minus 7 minus 11 is minus 18, so it's minus 3. So you get minus 3 and 2/3 for your x values. And sure enough, that's minus 3 and 2/3. So it matches, right? Has to. We're doing the same operation. So no matter what's on the right, if you can't factor, you can still find the x-intercepts using the quadratic equation. And furthermore, if you get a number in here that's negative, we're not working with complex numbers, so then there's no real x-intercepts. In other words, there's no x-intercepts if this number here is negative. So if you have a graph that looks like this, where the x-intercept might be 3, then there's no, well, sorry, where the y-intercept is 3, then there's no x-intercepts. Okay. So from this, you should be able to find x-intercepts at any time. That's when y equals 0. The y-intercept at any time. I know it's mysterious, but it's always just going to be the number c. And then be able to graph the quadratic, at least sketch it. Right? Labeling the x-intercepts and the y-intercept. So let's do some guided practice here. So I'm going to call this. I'm going to make another example here. 1. Now, on the guided practice problems which are about to come here, I want you to do this exhaustingly like I just did. Like it should take half a page and not just give me a little graph like this and say, oh, there's my answer, right? You need to go through these step by step and do it right because there's a lot of theory involved here that you need for the next step in this game, which is factoring bigger polynomials of degree 3 or more. Okay, so let's pick a fun example here, something a little challenging. We're going to let y equal 8x squared plus 26x plus 20. Okay, so here are the directions. And I want to see all these parts done. 1, find the x-intercepts if they exist. Okay. 2, find the y-intercept. You should be able to look at this and see that the y-intercept is at 20. All right? And then 3, graph the parabola, which is what you get when you graph a quadratic. Okay. And I think it's possible that this doesn't have. Well, let's just try anyways. Okay. So 1, to find the x-intercepts, we set 0 equal to 8x squared plus 26x plus 20. All right. This is even, and that's even, and that's even. So at least a 2 will divide out. Anything more? No. So we factor a 2 out and we get 4x squared plus 13x plus 10. Okay. Now if you divide both sides of the equation by 2, this guy cancel, and this thing still remains 0. So that thing just goes away. So now we're going to factor 4x squared plus 13x plus 10. And again, I don't know how you do it. You might guess and check your way through that, but I like to be formal. 4 times 10 is 40. And then I take the 13 here. I'm looking for two numbers when multiplied, give me 40, and when added, give me 13. So let's see, what are the factors of 40? 1 and 40, 2 and 20, 4 and 10, 5 and 8. Anything more? Nope. 8 plus 5 is 13, so those are our two. Right, so 8 times 5 is 40, 8 plus 5 is 13, okay. So now we make the box here. That guy and that guy are automatic, and then you go 8x and 5x. So, well, 2 and 2, I bet it's going to be 4x and x. 4x times x is 4x squared. 4x times 2 is 8x. X times 5 is 5x, and 5 times 2 is 10. So there it is. 4x plus 5, x plus 2. Okay, so now you solve this guy, and you solve this guy. So x equals minus 5/4 and x equals minus 2. Okay, this is the part where I get frustrated with students. So the x-intercepts are, they're the point minus 5/4 comma 0, and they're the point minus 2, 0. So we found the x-intercepts. 2, what's the y-intercept? That's the place on the graph where x equals 0. And again, you just pluck off the c here, so it's 0, comma 20. All right, and since the 8 is positive, it's going to open up. We dealt with that before, and I think it's pretty easy to remember. So let's do this now. We're going to graph x, y, like this. Minus 1, minus 2. So one of the x-intercepts is at 0, minus 2. The other is at minus 5/4, which is about right here. And this is going to be very sloppy, but it opens up. And intersects up way up here at y equals 20. And there's the y-intercept. Okay, look at this page from here down. This is what I want to see for all the guided practice when you turn this in. And this problem set should probably take you at least half an hour to get through, if not longer. When you're finished with each problem, there's a great program called Desmos, desmos.com. It is a Google platform. It's amazing. When you're done, plug this in and see if these three numbers match, because they'll show up right up on the screen. Okay. So again, this is your model. This is the level of workmanship I want to see on all these problems, right? Don't skip any steps. Label your axes. Write your x-intercepts down as ordered pairs, and your y-intercept is an ordered pair. Label the axes here so I see exactly that these points actually match up with this, and show me how you got your factorization. Okay. So here's your guided practice. On y equals 15x squared plus 52x plus 45, 2. Y equals 6x squared minus 21x plus 9, 3. Y equals 7x squared minus 23x plus 6, 4. Y equals x squared minus x minus 35. 5. Y equals minus 2x squared plus 4x minus 6. 6. Y equals 21x squared plus 25x minus 4. And remember, 1, find the x-intercepts. 2, find the y-intercept. And 3, make a neat graph that encodes all this information in it. I want to make sure I get these written down right. 15x squared plus 52x plus 45. 6x squared minus 21x plus 9. Y equals... Okay. And if it's not factorable, just say not factorable. You can still graph it, you just don't have any x-intercepts. And this should take you to the end of the period. I mean, this is 6, you know, if you're doing it right. I don't like even numbers. I'll do one more. Y equals 16x squared plus 44x plus 10. I hate even numbers. All right, so we're gonna do 7. This should take you to the end of the period. So make sure you turn it in before 4 o'clock on Brightspace. And then on Thursday, log into Zoom at 2 p.m. So Thursday is going to be the 10th. Log into Zoom at 1400. On Thursday, we're gonna take roll. I'm gonna ask you about these problems in this whole idea of using the videos, and take homework questions, and then decide how we're gonna proceed for the rest of the semester. All right?